Hi, thanks for watching this short video where I'm going to talk you through user testing. My name's Nick Dudley and I'm a physicist, and I've been working in ultrasound for over 40 years, almost half of that time with a clinical role. I've always had an interest in quality assurance, both of the equipment and the imaging process. User responsibilities go beyond formal testing, and you should bear this in mind when you're scanning. This means things like keeping the equipment clean and looking after your probes and cables. You should also always remember that the most delicate part of the probe is the lens, and you should take care of this by cleaning it carefully by wiping and not rubbing, and using materials that won't cause damage to the lens. Reporting and managing faults is very important. If you do everything else but don't do this, then your QA program isn't working. You need to report a fault when you see it, and make sure you've got a system in place to make a judgment about what action to take. Is it a minor fault where you just need to keep an eye on it in case it gets worse? Is it a more serious fault where maybe the equipment's still safe to use but you do need to take some action? Or is the scanner or probe unsafe for use and you need an immediate fix? Before you start testing, make sure you've got the right probes. If you don't have the same probes you tested at baseline, then you're going to find it very difficult to interpret your results. Physical inspection is the first part of formal user testing, but it's good practice to have a look at the equipment every time you use it. I've described physical inspection in another video, so I'm not going to describe it again here. Another check you should do at this stage is to have a look at the filters, which are probably at the bottom of the machine or underneath. These can get clogged up with dust from tearing paper towels and things, and if the equipment overheats, it can be a very expensive repair. Don't forget to record and report any faults. Before doing imaging testing, it's worth checking that monitor and hard copy settings are correct. On modern equipment, it's unlikely that they've been changed, but if they have, you need to make sure they're set correctly. The next task is to look at the in-air reverberation for each probe. The process is slightly different for linear and curved arrays and phased arrays, so I'm going to describe them in two separate videos. Here I'm going to show you the test for phased arrays. This is a fairly simple test, but setup is important as clinical settings can mask faults. We're going to use the paperclip test to look at uniformity, so we need the lens to be clean and dry with no gel. But for some probes, you might want to wet the lens with a little bit of water to make the paperclip run smoothly. At baseline testing, a preset for user QA will have been set up, so that makes it easy this time round. Just select the preset and check all the settings. Don't forget to check TGC, as that's one control that won't have been included in the preset unless it's a touchscreen control. We can't see dropout in the in-air reverberation due to beam steering, so we have to turn that off by using M mode with the M line central. Now we can look for any dead elements using a paperclip or a test tool like this. If the tool's placed across the array, because it has a narrow edge, it's in contact with a very small area that could be as small as a single element. The ultrasound reverberates in the tool, giving a comet tail appearance, which dims or disappears as it crosses a dead element. Make sure that the depth and focus are set deep enough for the whole array to be active. You can check this by touching the paperclip near the end of the array. If you don't get a signal, increase the depth and focus until you do. The best way to do the test is with a smooth sweep along the probe, then freezing the image to see the trace. I find I have to do a few sweeps until I'm confident about whether there's dropout or not. Changing direction helps as well. If there's dropout, it's important to check it's not due to the connector or port, so wiggle the connector, move it to another port if you need to. Connectors can get dirty, so cleaning with compressed air might resolve the problem. If the defect is still there, it's associated with the probe, which should be rejected. This all works for conventional probes. Some modern probes have several rows of elements, and the in-air reverberation is probably only telling us about the middle row, so we need to do the paperclip test for each row independently. Now, because the scanner only uses the outer row for deeper imaging, we need a deeper scale and focus for this test. We can find the rows by moving the narrow end of the paperclip across the array. Where the signal changes, that's the gap between rows. Then we move the paperclip along each row in turn. I find I have to do a few sweeps until I'm confident about whether there's dropout or not. The next test is sensitivity assessment. You should use the user QA preset. Make a measurement from the top of the image to the deepest reverberation line in the middle third of the image. I apply the rule, if you can see it, measure it. Compare the measurement with the baseline tolerance. If it's inside the tolerance, do the next part of the test. If out of tolerance, it's failed the test. Look carefully at the whole deepest reverberation line and turn down the gain until the line completely disappears. Do it again until you've got a consistent result. Compare this result with the baseline tolerance. If any results are out of tolerance, check the scanner settings and repeat the test. Unless the results are grossly out of tolerance, you can still carry on using the equipment, but you need to investigate by doing some sensitivity measurements with a phantom. Finally, turn on Colour Doppler and expand the colour box to the full width of the image. Increase gain to show slight colour speckling, then flex the cable at the strain reliefs and any point of visible external damage to the cable, looking for streaks of flashing colour. To sum up, user QA should be quick and simple. Look after your equipment on a daily basis. When you do formal testing, do a thorough physical inspection, check uniformity and measure reverberation depth and threshold. For a scanner with a few probes, this shouldn't take more than about 15 minutes.